price prediction. So as Soren says, I was a human being before I become businessman. So a lot of people are crazy about stuff. So am I. So what is stock price? There are a lot more information just other than just the price itself. This is the price based on each second. And and this is the price based on each day. There's the open price, the highest price in the day, and the lowest price, close price, and the volume. And this is the data we use in our project. So our goal is to predict stock price, the open price. And we tried four methods. The first one is the stationary ARMA model, and the second one is non-stationary ARMA model. And the third one is a hybrid model of exponential moving average and linear regression. The last one is the neutral network. So for the first one, first one is the ARMA model, and our data is the Google's daily open price. It's just one time series data from 2005 to 2011, and we spread the data into the training set and test set. And we follow the standard procedure, the box Jenkins procedure to build the ARMA model. Basically, there are 5 steps. The first one is stationarity checking and seasonality checking, and model identification and parameter estimation. And last one is the model checking. For the first one is to check whether the series is stationary or not. Simply, we use this test, and unfortunately, our data does not satisfy the stationary test, so we need to make it stationary. The way to do that is to do the difference, and very lucky our data become stationary after its first order difference, and then do a seasonality check. And since the stock price has no seasonality, and Google company's business has nothing to do with the season, so we skip this step. And the third step is to identify the model, which is to choose the order for the ARMA model. And there are these 4 factors to help us to do the identification. And yeah, what I did is to compute all the AIC value and VIC value, and we find that the ARMA 1.1 model has the best. It's the best one. So the next step is to do the parameter estimation for ARMA 1.1 model, and simply is just to minimize the error, the sum of square of the error, and we get our model it looks like this. And last step is to check whether the residual are independent, and we can use these 3 methods to do the checking, and we did all 3 of them, and it passed the check. So far so good. It's our prediction. It's horrible. Yeah, a lot of money. And if we cover this back to the original time series, it looks good. But if we zoom in, it's still horrible. And the standard deviation is $9. So why it is bad? So we plotted the AFC and PAFC of the difference series. This means that this time series is very close to white noise. So we are trying to model a white noise. So it can explain why the fitting is so bad. So we try to avoid this problem. So we will just directly model the original time series. And the procedure is basically saying identification and estimation, and we get a prediction. And interestingly, very interesting, we get very similar result. Almost the same standard deviation, and the second approach in these two terms are both 1 unit bigger than the first approach. That's because the first approach used the difference time series. Okay, so can we use other models like Arch or Gauch? The answer is no, because there's still auto regression model. If we do the prediction, we take the expectation, and it will be the same as the ARMA and auto regression. And they cannot handle the irregular volatility in the stock price. So what should we do next? The first thing coming to our mind is the discriminative method. So here we combine a lot more information, a lot more data, the close price, this, and we separate data into 3 training, test, training, develop, and test. So the basic idea for this hybrid model is to do the 10 lag exponential moving average for the 5 data series, and then you use those EMA results as features to conduct the linear regression on the next day's price. So here are the formula to calculate the EMA, and here is the feature for linear regression and label. So here's our result. It's very good, and it's much smaller. The deviation is much smaller than the ARMA model. So our last model is the neutral network. We still use the same data, and the network is like this. Here is the hidden layer. We use the previous step as hidden layer, and the 5 data series, and the previous steps arrow as the input, and we get the output here. Output here is the estimate of the open price of next day. And the learning method is for the weights of ABCD.
1 minute.
We use back propagation with gradient descent, and we try to avoid the local minimum. We apply this quasi-Newton method, and for the number of variables in this hidden layer, we use the validating. And here's the result. It's worse than the ARMA model, but it somehow catch the trend of the data. And we believe that this model has a lot of potential to be improved. First, if we connect the model like this, we can use this neutral network to model time series with lag more than 1 lag. And all last thing. The next is the system used the previous arrow as the input for the next step. So it can do the self-correction So we can take advantage of this property and to make the model with better prediction ability. The way to do that is to train all the data and get a final weight W, and then we go back to some point before the prediction point, and then we fix the weight W, and then we go through this training data as the W is fixed, and we update the layer S. So by doing this, we have a better probability to get. Okay, that's all. Thank you.
So while we're asking questions, why don't we have the next presenter?
So you making money? Let me know.
Not yet.